Okay. Few more seconds. Yeah, I think right now you should have seen it on the full screen. Perfect. Okay. I deeply apologize. So let's start from the very beginning. As I previously mentioned, Opgal been around for the last 40 years, manufacturing thermal imaging solutions for different applications, different industries, and in the last 15 years, we've been focusing on the OGI cameras and everything that has to do with the industrial application, especially on gas monitoring systems. We've spread around the globe in over 6 continents, working with 50 plus countries through our channel partners, sometimes directly. You can see the map here is actually indicating most of the countries that we are active per today. Some of our valued customers, you can find them from South America to Central America to North America, Europe, Africa, Asia, Central Asia, Southeast Asia, and basically all of the global players today, they're either familiar with Opgal, either they're currently working with Opgal. What we offer to those customers is the following solutions. We have the handheld devices, we have the fixed 24/7 monitoring system, we have the flying airborne system. They're all connected to the dedicated apps, software, and monitoring software. And a little bit more about the handheld devices and what we recently introduced in the last year. We have the IC-Gas Multi, which is, I can proudly say today that this is one of the most, if not the most sensitive piece of OGI equipment in the industry. It's a mid-wave infrared cooled OGI camera that is sensitive enough to detect up to 0.35 grams per hour of methane leak with a delta T of 2 degrees Celsius. It's EPA Quad OA, Quad OB, and Quad OC compliant. Of course, it's an intrinsical device, intrinsically safe. We had moved through different variation and different features within the camera. We called it multi due to the fact that we have the patented replaceable multi-spectral filter system that allows us to switch the filters and to move within the VLCs and within the CO2 detection. Again, it detects methane in over 400 different VLCs. It has a built-in quantification features, and as I mentioned, by far the most sensitive piece of equipment offered today. Again, we're offering some different and more interesting features such as free firmware updates. Our battery time is one of the longest in the industry today. It allows us not to go outside the field and change the batteries, come back, and so on. You can work long hours with the same battery. Then it takes minimal time to change it. We have the self-calibration feature, which is one of the most important things today. We're going to talk about it a bit later, but it's actually instead of preparing or sending the camera for annual calibration and so on, etc. The camera can self-calibrate and show you the results right before you're starting your survey, and that will give you a good indication in the field whenever it's ready to work or not. A little bit more of what we is going to offer is actually we have our IC-Gas app with the features for Android and iOS platforms. It has the wireless connectivity, remote controlling the camera and viewing, recording images. It's actually a very helpful tool in case if you're doing the inspection, you want to share the videos, you want to share the images directly from the field through your, let's say, WhatsApp or any other platform that you're using. It is very easy to share. It has the streams. It has a lot of features that help you to work seamlessly. We're recently added another feature. It's not ready yet, but we just added it in the trial platform that you can stream to remote users anywhere in the globe. From exact point that you check in to any office or any place, you just connect to the website or connect to the server, the remote place, and then you can actually stream from the field. which is very, very helpful tool and very unique to us. Of course, it's going to be, we're going to add up additional thing, which is the quantification capability. We're going to quantify the gas. We're going to, it will be a helpful tool through the inspection. You can not only quantify, but also to colorize the plume, and it will be a very, very good app to that.
We're going to add the quantification to the app.
Yeah.
We already have quantification in the camera.
So a little bit more about the built-in quantification. What we actually have right now, apologies. What we actually have right now is the built-in quantification feature, which allows you, when you do the detection, it allows you to see directly the gas. It will give you the leak rate in the middle in grams per hour, and with the same principle, it's gonna right now the built-in quantification is gonna also have the Excel spreadsheet report together with the file, and an additional feature that we're adding right now is actually gonna have also the QOGI file that will be recorded simultaneously to the video stream file, which is the TS today.
The QOGI file is data file, radiometric data file that we can use for validating the results before reporting, and we could do post-analysis using this, changing some of the variables of the quantification to do post-analysis and refining and optimize the analysis of quantification.
So based on that, we can actually do the validation of the recorded videos to help assess the skills of the operators, which is the major feature today. Of the data based on the skills of the operator. Right?
Yeah. So good morning, people in North America, and good afternoon, people in Europe and other places. I'm going to explain a little bit about the OGI technology, and this is the only slide that I'm going to have an equation on it. The rest of it, it will be pretty visual and not scientific as this one. But I'm using this one to just explain what is optical gas imaging camera. It's a thermal imaging camera that has a special bandpass filter that actually is in the absorption line of the detected gas, and thermal camera will measure the background over here, the background temperatures in every pixel of the picture, and or radiation that coming from this background image. But if you don't have a gas, it will be a very static image. But when you have a gas plume coming in, it will always absorb some of the energies that coming from the background into the camera, and the changes in this absorption in each pixel, this is the movement of the gas, the reduction of energy from the background temperature is what we see in the OGI, in the image of the OGI camera. So now the gas plume always absorb energy, but it also emit the energy, and the balance is about the balance between how much it emits and how it's transmitted is depending on the background temperature. So if the background temperature is higher than the gas plume temperature, it will absorb more than emits. So you will see a reduction of temperature in the camera pixel. But if the background is colder than the gas plume, like sky background, you will see in addition that it will emit more than absorb. And then you'll see an addition of temperature, increase of temperature in that pixel. So that's how we see the difference in temperatures, the changing, and we see the gas plume. And if there is no delta T, the absorbed energy is equal to the emitted energy, and we will see nothing, no change in the image as a result of a gas plume, regardless of the gas concentration and magnitude. So that's explaining why we need a delta T. Delta T is a very important feature for detection of gas in the OGI technology. If we have a larger delta T, we will have much more sensitivity of the gas in the OGI technology. The delta T, remind you, is the temperature difference between the background and the gas plume temperature. Now, what we measure, what we detect is the difference in each pixel of the energy or temperature when we have gas in between the background and the camera and when we don't have gas. So this contrast, this difference is what we actually measure, and we normalize it to the delta T, and this is proportional to the concentration of the gas that is tell you in this term, it's called the transmission. 1 minus the transmission is actually the absorption of the gas, and it's a function of the gas concentration, the plume depth, and the absorption coefficient in every wavelength. So what we actually measure is concentration. Once we measure the contrast, the normalized contrast by the delta T, it's proportional for each gas, for each absorption coefficient, for each gas, it's a function of the concentration length, which is the CL of the gas across that pixel. So CL is what we quantify. This is the baseline of our quantification and detection. But in order to move to into quantification and mass flow rate, we need also to integrate concentration across a plane downwind from the source, and we need to calculate the wind speed or put in wind speed and multiply it by the plane concentration, and we get the mass emission rate. So this is an example, a movie. And this is showing also the detection and what I explained about the delta T. You can see a black plume on a warm background, and this plume is turning to a white plume, addition of temperature, when it goes to the sky background up here. Now we are quantifying in a plane downwind over here, and we are integrated, and when the plume going outside the plane, actually you saw these 0 numbers. But when the plume come back in, we see this concentration and leak rates coming back in and calculated in real time. So we're going to talk today about the regulations for detection of methane, the US versus the European regulatory for LDAR services. LDAR is leak detection and repair programs, both in the US and in EU. It's a common, it's actually a regulatory requirement to do LDAR surveys. Now, this table describes the differences between the regulation that came out both in 2024, both in the US, it's called QOGI, QOGB and QOGC, and in EU, it's a parliament rule, actually law on methane. So the difference between the US and the EU is the technology in the US is required to be OGI for LDAR program. And therefore, they develop a method that is called Appendix K. It's actually the last few pages of this regulation describe the method how to conduct a LDAR survey using OGI. It's talking about the training, performance envelopes, and all kind of things that they added. The need to measure the delta T, the need to to develop the performance envelope and other requirements. And in the EU, it's actually not specifying the technology. It's just saying any technology that can measure methane above these three levels of these three types of LDAR surveys. They have three levels: 17 gram per hour, 1 gram per hour, and 5 gram per hour for different types of LDAR surveys. Any technology that can prove that you can measure down to these levels can be used to detect methane in LDAR survey. And in the US, they are not just focusing on methane, also on VOCs represented by butane and propane, and they have different values for each compound: 19 gram per hour for methane, 29 gram per hour for butane, and 22 gram per hour for propane. So the NSPS, New Source Performance Standards and Emission Guidance, QOGI, QOGI, in the US, as I mentioned, they have a requirement to use OGI in many applications, in many type of sources, in midstream and upstream, and these requirement can be in different periods of time, but they, in the end of it, they did the Appendix K. The two requirements that we are adjusted our technology to adjust for or to comply for this regulation. One of them is the self-calibration that Michael mentioned before. We are, every time we open the camera or every time we do a NUC calibration in the camera, at the end of that process, the camera checking in the background the noise equivalent temperature difference and convert it to noise equivalent CL. This is for methane at 10 degrees delta T. And if it's below 9 ppm meter, it's give you a green background, but you do it this process when you have the lid on the lens on, so it's a very unified surface, a unified temperature surface, and that's when you calibrate your camera with the lid on. When you take off the lid and you look at the background, it's probably, that's how we got the 70 ppm meter, and you get the red background. The camera, if you have the lid on and you get the red background, you send the camera for service. Yeah, we also save this calibration in the camera. We say we have a CSV file that it's called Calistory, and every time you do this process, it gives you the timestamp, give you all the detailed values of calibration for the history, and you can track your history. I mean, starting to get worse than 3, 4, 5, you know that something is going on your camera.
So basically, if the user, once he's going to the field before he starts performing any activity on some flanges or wherever on the sources, he can recheck himself and recheck the camera if the camera is calibrated and ready to perform for the LDAR job. So basically, it's a very useful tool. And as Ram previously mentioned, you will save the history, you will save the calibration data, so it will be on your log file, and it's a part of the compliance for the Appendix K.
And the other feature that we added is the measurement of delta T. You can see up here, we actually, once we automatically adjusted the air temperature in the camera, we can measure in the center here the temperature of the background, but up here it will give you the delta T. This is very important because some of the requirement on Appendix K is require the measurement of temperature difference, delta T. So Appendix K specify that any camera that can measure 19 gram per hour in 2 meter distance, delta T of 5 degrees and wind speed of 1 meter per second is suitable to be used under Appendix K for LDAR surveys in the US. But a camera that barely reached these levels will not have a performance envelope once the wind speed is going above 1 meter per second or the temperature difference go below 5 centigrade. They will not be able to measure the 19 gram per hour. The Appendix K also explain how you measure your performance envelope, and we did a lot of experiment, and we had a third-party experiment validation of our performance envelope under Appendix K, and we have two distances over here and two delta T's. One delta T is the 5 degrees, and one is almost ambient below 2 degrees, and the envelope is described on the wind speed that below this wind speed, you can go out and do your survey. So if you have your sources at around 3 meters and you don't guarantee a delta T larger than 2 degrees, you can go out and do up to almost 8 meter per second LDAR survey. But if you have larger distances, obviously the wind speed that you can go out will go down. But usually these long distance, you have good delta T because you do it on the sky background. So you can still go at 8 meter per second if you do it on delta T of 5 and up. So everything was validated by a third party, Xera in Europe, and we can show this that at 5 meter per second wind speed here, 12 meter distance, we can see 18.63 gram per hour validated by a third party, which is essentially the 19 gram per hour. In the European regulation, they have 3 levels, 17, 5, and 1 gram per hour for different type of, and these are the wind speed that you can see this level. For 17 gram per hour, at delta T 2 and lower, we can see 7, 4.5, and 2.5 gram per second. We added a rule from 2023, the California rule, South Coast AQMD, that required to do OGI inspections on tank farms, and actually it's a weekly, and this is like an LDAR on tank emissions. Once you see a visible emissions on the sky background from down below, you need to probably climb up the tank and see the exact component it's coming out from, if it's a floating roof, where it's coming from, and deal with it under this regulation. So this is another place that OGI technology take place in the regulatory framework. Now I'm going to talk about the OGMP, which is the Oil and Gas Methane Partnership. It's a UN program that actually required to quantify measurement-based quantification of site-level emissions and reporting. And it's a voluntary program that already more than 150 companies join globally. And once you join, you need to report your all assets emissions following the framework. But the important thing, it's a measurement-based reporting framework. And there are 2 levels that are on the measurement level. There is source level, which is called, source level 4, I'm sorry. Source level quantification, this is the level 4, and level 5, it's actually a summation of all your level 4 source level emissions and site level emission reconciled to your annual emission from your assets. So it's you need to do at least of 70% 100% of your emissions with level 4, which is source level, and you do some site level measurements and you need to reconcile and explain the uncertainties, or you can do 100% source level and much less. The only thing that you need to do is to make sure before you report your level 5 emissions that your level 4 and site level measurements are reconciled for level 5. But what is important here on level 4, that operators should focus on their most robust measurement efforts on reducing uncertainty associated with larger emission sources. And from our experience, the larger emission sources are not the small leaks close to the ground that usually are taken by the high-flow samplers, but this type of sources, where the vents that are on sky background, they are in kilograms or 10 kilograms per hour, and while the small leaks are in hundreds gram per hour. So we have like a factor of 10 or even 100 larger sources. So sometimes one vent can be more than 70% of your assets emission. And that's where we are focusing our quantification efforts. We actually optimized our analysis, and we'll show you a video in the end how we do this quantification. We believe we do it the best, and we actually going to show you some evidence in blind testing and comparison between other QOGI technology that our quantification is the most accurate on these larger sources of emission. Yeah.
Just wanted to add that Opgal today with a icy gas product line is the only company that is capable of actually having an OGI quantification capability on those remote sources. For instance, we are capable of quantifying a huge source or a big source of a couple of kilograms from tens meters away. Like the recent one we did was like 70 plus meters away. And the results were pretty good. It's not pretty good, it's actually excellent. But the thing is that all of the other competing devices today are not capable of getting this data and actually proving that their data is valid.
Yeah, and to get these sources accurately, you did most of the work of reconciling this with the light site level emissions, because if you do one vent or a couple of vents and there are 70, 80, 90% of your site emission, it's very easy to reconcile it with the flyover or continuous monitoring at the site level. And this is the most important under OGMP framework to get these reliable source emissions. So we participated in the European Gas Research Group, GER group, studies. The first phase was a blind studies, and they have 10 technologies that were tested, control releases, often known amounts of methane. And you can see the top 5 are site level, and the bottom 5 are the source level. And we are OGI 1 here, one of the source level technologies. And here are the graph of the performance. So the 5 bottom graphs are for the source level. This is the high-flow sampler, which can take only small leaks close to the ground. And all the other data points, which were the remote vents with the higher emission rates, they are not reporting anything. But the 3 middle one are the OGI technologies. We are OGI 1 in the middle, and all the vents and remote sources and larger emission sources, we are the only one who got any close to the red line. This is, you can see down here,
a completed device.
It's a other QOGI, very known one. You have no data point inside the ellipsoid. And this is another European-based QOGI. And also they are outside this ellipsoid, and And the main reason for that, and this is already published in a peer-reviewed paper that is being cited very intensively in the last year. And you can see it's atmospheric measurement techniques. And you can have all the information in this peer-reviewed paper. But the point is that we can do remote, inaccessible, large sources, and we can do it pretty accurately. And the second phase of this, and I would say that the main advantage that we can deal on sky background with cloudy skies. The other OGI, QOGI, and we can deal also with large distances for two reasons. One, we take into account atmospheric attenuation, and the other thing that we take into account, we have the multi-filter that allow us to go longer ranges. But if we look down here, we look at the second phase of this study. The second phase was a reconciliation study. They took a compressor station, divided to different areas, and they had all of these top-down, site-level technologies and continuous monitoring. And they chose only one source level, and they chose us based on the first study that we were the most accurate. So we were the only source level that was trying to reconcile to the site level. They had some high flow samplers to leaks close to the ground, but we are the only bottom-up source level technology. And what we can see here, this report is not published. It's belonged to the members of this GER group, research group. It's 15 companies. They did not release this, but that's why I don't mention the names of the other technology, but I can report that our results were excellent. Area by area, we reported the highest number of leak detection because they didn't tell us where are the leaks. We had first to find the leaks and then quantify them. So we found the most leaks, and then we reported area by area, and we achieved 100% of reconciliation area by area. You can see the other performance statistics, which is we have another one that got 100%, but they have only 5 leaks and only 2 areas that are reported. So, and then we took all of these areas and tried to reconcile the site level emissions in 2 modes of operation. Mode 1, the compressor doesn't work, and mode 2 is one of the compressor in the station works. And you can see that in both modes, we achieved reconciliation between our level 4 source level and level 5. And the other technology, most of them were site level technologies. Some of them missed some of this reconciliation goal. So in summary, Opgal OGI technology, mostly we were talking about the handheld portable technology, is compliant with both US and EU methane and VOC regulatory detection requirements. It's not just complied, it has the widest performance envelope. We believe that if we're required to measure 19 grams per hour of methane in specific conditions that are 5 degrees, very close, low wind speed, we actually in 5 degrees delta T, we can see 0.17 gram per hour. Okay, in delta T of 2 degrees, we can see the 0.35 that Michael mentioned in the beginning, that in our brochure, we're saying we can see 0.35 gram per hour at 2 degrees delta T. And this is in low delta T. In 5 degrees delta T, we can see half of it. We can see 0.17 gram per hour. So we have a lot of room. We can use much higher wind speed, much longer distances, and still see the 19 gram per hour. So this is how wide is our performance envelope for detection, and both for US to see the 19 and for EU to see the 17 and even the 5 and 1, we can go out in windy conditions and no delta T elevated, and we can still perform this LDAR survey with our camera. Now, as far as level 4, we believe that level 4 will benefit a lot, and reconciliation will be much easier if you get these large inaccessible sources quantified reliably and accurately. So we think we are the best technology for doing this. And I will run this event that we do quantification. In a second, the leak rate, there is a delay. And now the leak rate is coming up. We have about 1 kilogram per hour. And you can see this is on a cloudy sky and high wind, cloudy sky. But all of a sudden, they shut off this compressor vent. And you can see the numbers go to 0. But what is really, really impressive in this, now the clouds come into the plane, and you would expect that
the rest of the OGIs will probably quantify those clouds.
Yeah, but then it opens the vent, and all of a sudden it's seeing the gas. So our algorithm has some AI capabilities to differentiate between the cloud movement and the gas movement, and really do a good job of differentiating. And then one point that I want to make, it's good, it's the best, but it's not perfect. And we still think that a lot of the error of doing quantification with QOGI software will be the user training. If Appendix K require only for detection using OGI hundreds of hours of training and experience, we think that to do quantification right using QOGI software, regardless of what software, will need a lot of training until the user know how to apply it. And therefore, we offer this program that we added to the camera. Every time we do QOGI software, we do save the data file. You can upload it or send it to us, and we will do your validation, and the operator will get feedback, what he did right, what he did good, and what he did not so right. And you get feedback, and next time you will be doing, it's like a back and forth online training to do it, to optimize it. And eventually, when the operator will be well trained, he will send it to validation, and every time he will send it, it will be validated because he knows already how to do it. And that's about it. We are open the floor for questions.
Great. Thank you very much, Dr. Hashmonay. It's very important that we had this platform to introduce the products, to introduce the difference of the technology and what we are strong in, where we can actually leverage on the other existing technologies and the competition. And yet again, what Dr. Hashmonay has mentioned, when you have this raw files, where you can send them to the platform and share them, and that will actually help you to improve your quantification. Not particularly yours, maybe one of the participants here is a super master of QOGI collection videos, but the new operators, it's a very helpful tool to get them on board to this, what we call the cult of QOGI thing, and to get them more skilled and get them more professional at what they're doing. That will give them, a confidence to go on field and to actually to report this data and to feel confident about the data that they're reporting. So let us go through the Q&A session. That will be right now. Just 1 second. Again, today we're having a kind of we're a little bit technologically challenged with our platform, but if you have any questions, I will be happy to reply, and please feel free. Just raise your hand or just drop them in the chat, and we'll go through the chat and see what we can answer. Okay, we have some activity.
Yeah, but
Yeah.
can you type in your questions because we?
Okay. Okay. Yes. So SCFM flow measurement would be great for QOGI compressor when flow to verify it is within the limit. If Opgal gets to that level of accuracy, it will be a game changer, right? There is a question, can satellites be used for the site level?
It's out of the topic. I'm not an expert on satellite, but from what I know, it will be for the super emitters, but site level, it will be site level periodic screening require the highest level, I think it's 10 kilogram per hour. They have different levels. They have 1 kilogram per hour and 10 kilogram per hour under QOGI for periodic screening. And satellites cannot go down below a couple of hundred kilogram per hour. So
120 kg
what?
Of methane to be visible on the satellite. As far as
no, I think in special condition you can go, but couple of hundred is more. So it may be the super emitter program under QOGI, QOGI is required for technologies to be above 100 kilogram, to see down to 100 kilogram per hour, and that's where satellite can be used. But some other airborne platform closer to the ground can do, and actually been approved. Drones and airplane has been approved as periodic screening at different levels.
There is another question. Is the remote access to the iOS app available now? Remote from different location to the scan site. Well, right now it's not. We're still in the trials. We will get you a notification. Everybody who's actually at this webinar today with us, attended this webinar, he will get a notifications one. We're going to have this feature open to all of our customers. And yes, iOS will have that.
Yeah, and everybody who has already our customer will have this information for sure.
Okay, what security features or certifications do you have to prevent anyone from accessing remote sites, cameras? Well, basically that will be like a WhatsApp. It will be a closed link, like self-decoding one. So it will change a couple of seconds. So only the operator will have that and can share the link with the remote viewer. So the remote viewer will just log on to that, and that will be visualized by this. Only those two people could do that, unless the operator will share the link with other people. Okay.
Okay, I can explain. Every day when you open the camera, it will check the noise level and the sensitivity of the detector.
And Gallagher Bob is asking, I believe you mentioned that the daily self-check calibration files can be saved, transferred, and printed. Can you verify and describe the process?
There's no process. You just download the calistory. The name of the file is calistory. It's calibration history, and it's an Excel format, and you download it from the camera. Once you erase it, next time it's doing calibration, it will open a new one. So every time
It's like
every time you do a calibration, you check if it has a file on the camera, it will add a line with the timestamp and all the information of that calibration. Once it's been deleted from the camera or moved from outside the camera, it creates a new file. But it's a file that is saved in the log directory on the camera.
Okay, there's another question. Can you share the typical error difference between the OGI and the high flow technologies?
Yeah, OGI technology is more challenging to do in QOGI, and when you have a very changing background and close to the ground and small leaks, the eye flow will be more accurate when you actually verify with the OGI that you vacuum or you captured all the plume from the leak into your flow sampler. You'll get pretty accurate flow rate from the eye flow sampler, but you cannot get anywhere, and it's limited on the levels, I think, that you can take, and it's really cumbersome to go and climb with a scissor jack or with other platform to these elevated and hard to reach sources. So the OGI is more suitable. That OGI, I think iFlow sampler cannot be used without OGI. So you already have your OGI in the field. So you do the major sources, the large sources with OGI, the remote sources with OGI, and the other leaks, the other, less than 50% of the sources you do with iFlow samplers, and you can do a comparison. You can do both. In sometimes even the OGI can do good job, but it really depends on your delta T, the wind speed, and the homogeneity of your background to do a really good QOGI on these complex conditions. So I would say complex conditions and close to the ground and small leaks are better with iFlow samplers. Inaccessible large leaks on the sky background, no question, QOGI, our QOGI, not every QOGI, can do the best.
So, ladies and gentlemen, if you have any further questions, we're going to give it another 2-3 minutes. And if not, we're just going to end up this session and prepare for the next one, I guess.
And we are always open to questions. We're going to share this video of this this webinar, and we are always here to answer questions.
Okay, I'm going to give it another couple of seconds, and then we're going to wrap up. Okay, when capturing leak videos, are they able to be shared directly from the camera, or they must be shared via WhatsApp? So that's a great question, and that's what we actually talked before. There will be a capability once your camera is connected to the phone. Your phone is going to generate the software on the app, going to generate the link, so you can share that link with let's say with your colleague in the office or your manager, whatever you want to share with. And by just clicking on that link, he will be able to join your session and see what you're doing from that point. So yeah, that will be.
We have a question about the California, and this is a very good question. I neglected to mention that our camera is the best for the California because we have the icy gas multi that we can replace the filter to measure VOCs on remote sources. We actually we can go hundreds of meters and kilometers to see these vents. So 60 meters are not a problem for us. It's actually, we have you can replace your lens to a 75 millimeter lens, and we actually see vents from kilometers away. and we can share with people who are interested some videos. So you don't need to walk around much. You can do it from few strategic places and pick up all the visible, very small emissions from very large distance with our camera. And this is very unique to our cameras because we have the long range filter, and it's doing the VOCs much better than the other OGIs because it's getting away from the water vapor in the atmosphere absorption. So especially in places like Texas in the summer, or South America, tropical places like
Brazil, especially.
Brazil, this camera is the best for measuring tanks from distance. So
Are the video links able safe for sharing later, or must be linked to each and identified later created individually and shared right away? So it will be like an online transmission. We didn't thought about saving the videos right now, so we're talking about the online capability at this moment. But I guess if there will be, we're basing our part of our R&D on the feedback that we get from our customers, and if that will be quite a demand, we will definitely add this thing and might consider just adding this feature to the soft as well.
thank you very much, guys.
Gentlemen.
We are very sorry from the technical issues in the beginning.
Yeah, we had some struggles, but eventually we made it. So thank you very much for joining today. It was a great pleasure, and hope to see you next time. Take care.